At least you're talking.
Iwe, chongo.
Ndeumfwala ndeni.
Basa, tuma notes basa muletu man. Kaili na abudira ma notes basa. Especially wildlife.
We tamwale chitafi atende chwele monekera tinaya mulira.
Zire.
Basa. Especially wildlife basa.
Naya mulira.
Chepa ma. Kaili ama stations tu akwa.
Okay.
Stations tu
Now,
okay.
GIS.
Okay, awelekeni tupuishe twala pituluka motumone ama handouts tuchaide, then I'll be able to correct that none. Mwamfate?
Okay, thank you. Basa.
No worries, we'll make sure namkwata ma handouts.
Not basa.
Okay, let me just now move over and get to the PowerPoint. What I have today. Well, good morning, ladies and gentlemen. Well, thanks very much. This morning, we want to continue under our huge topic, which is sources of digital and geographical land information. And let me just call this one a reminder of the GNSS that we did when we are dealing with the surveying. And if you remember very well, there was a point where we said the GNSS is key in GIS, okay? So as part of our introduction, we are saying that there are various global navigation satellite systems that are being operated by many countries today. A number of great powers are running these. For example, the Navstar, which is operated by the United States of America. We have Gnss, which is operated by Russia. Okay, we have Compass or Beidou, operated by China. Rwanda recently launched some satellite in the sky. We don't know what they are up to, but there are so many. Even Europe is running Galileo, so there are so many GNSS systems being operated today. Okay, and then we are saying that their use in any kind of survey or GIS work depends largely, to a large extent, on the money. Do you have the money to buy the equipment? You can go on eBay, you find these equipment very, very expensive. Some of them, minimum you can spend, it's about 100,000 kwacha ukuya pamuru. That is good quality equipment you use and you make money. Okay, it also depends on whether you have the skill and the training. That skill, you know the skill. We did this GNSS in land surveying last year, and you were trained to do these things. Now, if a person has not been trained to do things, trust me, it's very difficult. I've seen in some places people were telling us, ni kamera yomkwete, nishivale vamona nani, vamona theodolite, nangutoto station, iye vale tukopa, and things like that. So it also depends on the skill and the training of the personnel available. If you have personnel that cannot operate the GNSS equipment, then it becomes difficult for you to use these equipment. Okay. So we move forward and have a look at GNSS for GIS or remote sensing. And firstly, we are saying that GPS or GNSS may be used to identify or refine geographical coordinates associated with satellite imagery. Okay, GPS is used to reduce distortion and improve on the positional accuracy of these images, which is true, okay? Which is true. When you get these images, sometimes you have ground control points, which are just spreadsheets, files of data with coordinates. So you can insert them on satellite imageries to improve their, to refine their geographical location. Okay, we the accuracy there. Then second, the GPS or GNSS can be used to ground truth satellite images, especially when you are carrying out the image analysis. You may guess, that feature looks dark, I think that is water. Oh, that one looks white, I think that is sand. And then you take your GNSS equipment, go to the field and ground truth. You did ground truthing in that assignment I gave you. I wanted you to have an idea before you we even come to the issue of ground truthing. That was the essence. So when I'm talking about ground truthing, I'm sure you know better than I do, because you went in the field, you identified features on a satellite image. Then you went to the field, ground truth. Oh, this is a water body, this is what. I haven't even marked that assignment. But yes, what you did then was ground truthing. Okay. Then thirdly, GPS or GNSS data has developed into a cost-effective tool for updating GIS or CAD systems, which is computer-aided design systems. So, away from why we use the GNSS in the GIS, we move forward to the process of surveying. And the process takes the same format that we began with in the first year. First, you have to do reconnaissance. Second, you have to carry out observation and measurement using your GNSS equipment. Third, you have to present the results. These can be in forms of maps, images, in forms of bills of quantities, in forms of tables, in forms of many other ways, provided they are suitable. Okay, so as I said, I'm just reminding you of what we did in the first year. Two broad categories of GNSS measurements. These are the two broad categories. Every measurement you find will fall either in one or the other. There's nothing, no exceptions, although you could have a mix of the two. Okay, so the first one is autonomous mode, where you use a single receiver, like karaka receiver mwale bomfyaru ya mwaile mufield mwaya mkuchita ground truth kalifekanga kamo. That is autonomous mode or single receiver bane. Then the second the second method is differential mode. Okay, this is highly accurate GNSS, which involves two or more receivers, and corrections are sent to such devices to correct for error. Single receiver or autonomous mode, that one is prone to error. So with a GNSS system that broadcasts corrected position from a reference station, two or more stations. One is set per base, and the other one is a rover. You move with it. How I wish I could show this equipment physically. You touch them because you know you need to touch them. Akamwenso kali akafuma kali akamwenso. Okay, away from those two broad categories, we have GNSS equipment categories. The first one amongst these is phase differential or survey grade, which is of the highest level of accuracy. And we are saying we are literally down to millimeter accuracy. This, my friend, is the equipment you use to do surveying, because survey, as I've said, is high accuracy work. So if you have phase differential survey grade, this you use it for surveying. And for surveying in those areas which ngawa pusako feka centimeter karandi kuti kale kabushe fyombo, like in the Gaza, like where there are a lot of expensive minerals, you want accurate determinations. So as you go in the field in Amapwisha, don't go and use the autonomous GPS for surveying purposes. Look or tell them to find the phase differential. So phase differential is SAT. This one you are seeing here, A. This is a base station, mwasha pa base, in area mwasha. Then you move with this rover here. And then you control your own pa base using this system. Area na internet. This is phase differential value. Oh, sorry, not Bawish. Guys, okay? So corrections are supplied in this case. And the other grade of GPS or GNSS equipment that you find is differential, which is mapping grade, suitable for GIS. So this is an example of a backpack, okay, with a receiver there, as you can see. It looks like that, okay? A pole, na receiver, then naka controller pad. So corrections are supplied, and this is sub-meter to 5 meters accuracy. Like our handheld receiver is how many meters accuracy? 3 meters. So then finally, amongst these grades, we have single handheld receiver or autonomous mode, which is consumer grade with no corrections supplied, and it's less than 10 meters accuracy, I mean. Okay, then what are the two broad GNS survey methods? Okay. We are saying that checks should be built into the survey by taking extra measurements as you are doing your surveys. And the first of those two broad survey methods in GNSS is called static, where the receiver is left at a station and it takes measurements over time, and then it calculates the average for more accuracy. Okay, so the receiver will take observations about every 15 seconds for an hour or more, okay? And this eliminates errors. Then the second broad category of these measurements is what is called kinematic. And here the receiver is moving with an aerial carried on the pole by the surveyor, just as you've seen. Okay, you can be either on a vehicle, on the ship, or on a boat. You are moving, and as you are moving, the receiver is once the receiver is initialized, it is locked onto the satellites and it is measuring as you are moving. Okay, so now with the advancement now, this kinematic, this is where now we have RTK, real-time kinematics. You are measuring something in real time. Are we together? Okay. So corrections can be carried out on the fly, RTK, okay, real-time kinematics, or post-processing. When you are in the office now, working on the data, the record, you do those corrections. And this method is used in detail survey, setting out and earth-moving machine control with centimeter accuracy. Okay, So this diagram here is just an example of satellites there, okay? And then we have processing centers, the user here, just to show you how these things work. Although we cannot see, sometimes we cannot see satellites in the sky there, okay? So in conclusion, we are saying that integrated systems with internet, GNSS and the total stations today are in wide use. I had an opportunity of using these equipment where we had the robotic total station. We also use the internet. Then we were using internet. We were using robotic total station, and we were using RTK, iria nani kinematics, iria, okay? So we were doing survey, nani topographic maps for people. And the company I worked for, they were making good money. But now these, you know, are very, very important in the management of natural resources. Okay. So then, class exercise. Explain in sufficient details the process of surveying when using GNSS equipment. This should be exercise number 10. I think this is what I wanted us to share this morning. Thank you very much. I end here for the first session. Yes, please, I'll be listening now. For those who want to say something, things, you know. Guys. Chris, I'll unmute you, Chris Mulandi. Chris, you are on. Good morning.
Yes. Good morning, sir. How are you?
I'm fine, thanks. How is Lusaka?
Lusaka is very fine. It's just a bit cold. We are busy drinking hot water around so that we keep warm.
Oh yeah, that's very important.
How is the copper belt there, sir?
Wow, as usual in Mwekera, quiet and you know.
Oh yeah. I wanted to ask on the class exercise on which we are supposed to measure the distance of that the forest, the intact forest, the other part. The first one you had used for an example, but the other part you said is a class exercise for us. I wanted to find out, how are we supposed to submit it? Are we supposed to capture a picture after we do the measurements, then send it to you via email together with the other class exercises, or that's what I wanted to find out.
Yeah, I think it would be better you capture an image and then submit together with other exercises.
Okay.
Yeah, I think that's a better
that's all
way.
for me. Thank you so much.
You're welcome. Thanks.
Right.
Vachanda chamulelanda lero. Vamusondala nentumfwe. Vachanda chamulelanda lero. Elijah. Namufulwa lero.
Awe.
Alendera nentumfwe. Okay,
tafali.
Okay.
Nachilandira limo pa handout.
Okay. Awe, kanchinomba pa. Let me just leave the session. This is what I had for us to share in the morning. And at 11 hours, we'll be dealing with another source, which is natural resources records. And I don't think it will be a long issue as well. Okay, let me just talk with Marvin, Mr. Mtoma. Mr. Mtoma. Mr. Mtoma, I wanted to say something. Yes, please.
I wanted to ask for a favor for some of us that missed the previous lectures.
Okay.
Maybe you can assist us with the videos, like the recordings of the whole session, because some of us have got a problem with power here.
Yeah, you are right. The problem is the
Yes,
videos are huge in terms of size. So to post them on our WhatsApp group, it's a challenge.
Okay.
Otherwise, I'm supposed to submit those to you.
Yes, sir.
Yeah, yeah. Now, most of them are beyond
All right,
25.
Can they be sent via email so that we can send the emails? Guys, some of us have been missing. I've only attended this one.
Okay, how much maximum size is email? Is it not 5 as well?
I'm not sure, sir.
Okay, maybe we can try Google Drive. We'll see.
All right, sir.
We'll see. Yeah.
Yes, if I find another solution, I'll let you know what we can do. Maybe try to partition them, cut them, then send them in phases.
Indeed. Thank you very, very much. I appreciate that.
Thank you very much, sir.
Okay, now I'm leaving because we are done.